Chemists study how substances mix together and how some don't. Here's an experiment you can do at home to demonstrate just that. Chris Saunders and Christina Matasha are chemists. They're in my kitchen to show you how to do an at-home chemistry experiment.
So let's take a look at some common things first that don't mix together. And you might be familiar with these, but we're going to take some water and some oil and mix those two things together and observe, do the two things mix? Is there a layer of separation? So we've just got some vegetable oil and some water. And so you'll notice, right, so kind of the globs, you'll notice that the oil is kind of floating on top. And you give that a little stir, and even though we try to mix it, it might mix for a second, might make little globs, but if we stop, you'll notice that the water and the oil still will separate. So in general, waters and oils or water and fat don't really mix well together. So let's take something then that is going to mix really well together. So we've got some milk over here. Now milk is a complex mixture. A lot of it is water. So if you drink a lot of milk, you drink a lot of water, but it also has proteins and fats in there, not dissimilar to some of the oils and the fat compounds found in that vegetable oil. So let's mix some water with the milk and see what happens to see if they mix. So again, the milk has fats in it, things that we show that don't mix well, but let's see if it mixes up in this case. So taking a look at that, it looks now just like a container of milk. We've just diluted it with a little bit of water, but we don't see any sort of separation. So the fats and the protein in there must be in a form that still dissolve in water.
But a lot of milk products, like yogurt, don't exactly look like milk. So how do they make that product when milk dissolves in water?
So part of that is mixing the milk with certain chemical compounds that can change the shape, change the structure of some of those molecules that make them no longer dissolve in that water. So one of those ways is to add an acid, something like vinegar, to that milk. So we're going to take some vinegar and mix it with the milk and watch what happens.
Take a coffee filter, fold it in half, and then in half again.
Once you look at it from the top, you can see that there are now 1, 2, 3, 4 layers in your filter. You're gonna put 3 of those filters together, three of those edges of filter together, and then 1 off all by itself. And you can see that this is, on the very bottom, it doesn't sink through anymore. There's no hole in it. It's all just one coffee filter. Then you can put that so that the 3 sides are together and one side opposite in your filter. So that way we can keep stuff from going through. It's a little bit of a block. So now that we have our coffee filter ready, we're gonna start to make some dairy products. So what we need to do this is some vinegar, which is acetic acid. So that's the acid that Chris was talking about earlier, and some milk.
So remember, in that milk, there's a lot of water, but there's also a lot of fats, and there's also a lot of protein. You may have heard someone tell you, oh, you need to eat more protein, or there's a lot of protein in that dairy product. So think about ways we might get that protein out of that milk.
So fill the cup about halfway up with milk, and then add about another 1/3 of vinegar in there.
Now, making my observations, I don't necessarily see anything happening yet. No, so at a closer look, I can start to see some separation. So maybe we can mix that up a little bit. So what you'll expect to see is it will start to get maybe a little bit chunky. So that solid material is stuff that no longer can dissolve in that water, or in that vinegar in this case. Now with it all mixed together, it's kind of hard to see what's going on. So we want to be able to separate those two things. So that's what we're going to use the coffee filter that Christina prepared to see if we can separate now those two layers. So here's our filter.
Yeah, another observation. So this is our water and our milk put together, and you can see that it looks one smooth and continuous. On our container, even though it's hard to see the solid chunks, you can start to see that there's something collecting on the sides. So let's see if we get any solid out of that. So take your your mixture, make sure that you have your filter on top of another cup that will hold just the same amount of liquid, so the same size of cups. And then you want to pour a little around the edges until that filter is about half full, and then wait for it to filter. Now, if it's taking a little bit for that filter to come through, you can grab the top of your coffee filter and start to squeeze the liquid out. Coffee filters are really good at keeping solids in and putting the liquids through.
Oh, now we can definitely see.
There's definitely some solid that has been collected.
Yes.
There's definitely some solids that have been left behind after we take out all the water. There's a little on my hands, a little on Chris's finger right there. This, in the cheese making process, is called curds, and you might have eaten cheese curds or see them in the store, and the water liquid that comes out at the bottom is called whey. Curds can be used to make our cottage cheese and a lot of other dairy products, and the whey is retained and that protein can be used in other places. But that's how coffee filters and cheesecloth separate out the solids from the liquids in the cheese preparation process.
This process of getting something out of a dissolved substance is used in lots of different ways in addition to making cheese, and it's just one way chemists impact our lives. If you want to learn more, head to the Science Trek website. You'll find facts, links, games, material for educators and parents, and much more. You'll find it all at sciencetrek.org.